So when we look at this question, they have provided a complex number z is equal to 2 plus 3i divided by 1 minus 2i. We have to express it in the form of r into e raised to I theta. That means we have to express this complex number in the form of an exponential form, r into e raised to I theta, where r is greater than 0 and theta is between minus pi and up to pi. These are the conditions provided. So this is the common condition for argument, where theta is the argument between minus pi and up to pi. Okay, so let's make z in the standard form. Let's make it as a bit more simplified form. So we have z is equal to 2 plus 3i divided by 1 minus 2i. So here, to make it as more simplified form, let's take the conjugate of 1 minus 2i. Take the conjugate of 1 minus 2i. Which is 1 plus 2i, and multiply the conjugate in numerator and denominator. So we get, so what we have to do, multiply the conjugate in numerator and denominator. So we get z is equal to 2 plus 3i multiplied by the conjugate 1 plus 2i divided by 1 minus 2i multiplied by the conjugate 1 plus 2i, which is equal to, when you multiply the numerator, we get 2 plus 4i plus 3i plus 6i squared, all divided by, it looks like a minus b into a plus b. So which is 1 squared minus 2i squared. And that is equal to 2 plus 4i plus 3i is 7i plus 6i squared, and as we know I squared is minus 1, 6i squared become minus 6, all divided by 1 minus 2i squared, which is 2 squared into I squared, which is 4i squared, and you know 4i squared is minus 4 as I squared is minus 1. So we get it as minus of minus 4 as plus 4, which is equal to minus 4 plus 7i all divided by 5. If we simplify it as still, we get it as minus 4 by 5 plus 7 by 5i, which is in the form of x plus iy, where x is minus 4 by 5 and y is 7 by 5. So we get the value of x and y. Now we can make the preparation of exponential form. For that, let's find the value of r. You know r is mod z, which is equal to under the root x squared plus y squared, which is equal to root of minus 4 by 5 the whole squared plus 7 by 5 the whole squared, which is equal to 1.61. So we get the value of r. Now let's find theta, which is the argument of ez. So to find argument of z, which is equal to theta, let's make a plan, a rough diagram, Argon diagram, which is real axis and imaginary axis, and the point minus 4 by 5 and 7 by 5. It lies in second quadrant, as the x-axis is negative, and y-axis is positive. It lies in the second quadrant. So if we consider this point as A, the point A minus 4 by 5, 7 by 5 lies in quadrant 2. And we know in quadrant 2, theta is positive. In quadrant 2, theta is positive. For finding the theta, let's join OA, which is the position vector Z. So OA is the position vector Z, and we found the length of OA already as 1.61. Okay, and theta, which is the argument of Z, is an angle between positive real axis and the position vector. So theta, argument of Z, is the angle between positive real axis and the position vector. So this angle is theta to be found. But to find that angle, we need to find out another one, which is known as this one. Let's name it as alpha. So to find the value of alpha, let's complete the right triangle, in which the vertical length is 7 by 5 and the horizontal length is 4 by 5. So that we can find alpha using tan alpha is equal to opposite side by adjacent side, that is 7 by 5 divided by 4 by 5, which is equal to 7 divided by 4. Therefore alpha is equal to tan inverse 7 by 4. So we got the value of alpha. Now to find theta, we need to calculate the value of theta. To find theta, what we need to do is subtract alpha from pi. From pi, if you subtract alpha, we get the value of theta. So therefore theta is equal to pi minus alpha. That is equal to pi minus tan inverse 7 by 4. Pi minus tan inverse 7 by 4, which is equal to 2.09. So now we got theta as 2.09 and r is 1.61. Therefore the exponential form is r into e raised to I theta, which is equal to 1.61 into e raised to I theta. As theta is 2.09, we get 2.09 I as result. In the next part of the question, question B, on an Argon diagram, sketch the locus of points representing complex numbers Z satisfying the equation mod z minus 3 plus 2i is equal to 1. Find the least value of mod z for points on this locus, giving your answer in an exact form. So now this part of the question is dealt with plotting the locus of this given equation on Argon diagram. So before going to the Argon diagram, let's simplify this equation. So when you get an equation like this, let's make it as like mod z. If you take the negative outside, we get it as minus 3 minus 2i, which is equal to 1. Now it looks like mod z minus z1 is equal to r, where z1 is the center of the circle and r is the radius. So we get, when you compare these two equations, we get z1 is equal to 3 minus 2i and r is equal to 1. So as z1 is 3 minus 2i, we can conclude that the center is 3 minus 2 with a radius 1. Okay, so now it's a turn to draw the locus on the Argon diagram. And you know, if the question is in the form of mod z minus z1 is equal to r, the locus is a circle with center AB, that is z1, and the radius r. Okay. Now mark the center of the circle, which is 3 minus 2, 3 minus 2. That is the center of the circle. Let's denote that one as Q, 3 minus 2. And as a radius 1, draw a circle. As radius is 1, it passes through minus 1, 2, 4. So your circle will be almost like this. So draw a proper circle. So we get a circle with center Q, that is 3 minus 2, and radius r is equal to 1. Okay. Now our question is to find the least value of mod z. We have to find the least value of mod z, where you know what is z. Z is the position vector OP, where P is the moving point. Which is on the circumference of the circle. So on the circumference of the circle, if you mark a point P and the vector OP is considered as Z. So the point P can be anywhere on the circumference of the circle because P moves. The movement of P makes this pattern, this shape, which is considered as the locus. And here we want the least value of mod Z. That means if you want the least value of mod Z, P must be close to origin. So if P is here, P is a little bit far away, and P is here. If P comes here, that will be the longest one. Okay, it goes like this. If P comes here, it will be the longest one, and if P is here, that gives the shortest distance between O and P. Okay, so that we have to find the length of OP, which is mod Z. Let's see how to find that value. Now to find the length OP, first let us find the length OQ. Let's calculate the length OQ. Which is mod Z1, that is under the root A squared plus B squared, where A is 3 and B is minus 2. So we get that one as square root of 3 squared plus minus 2 the whole squared, which is equal to square root of 13. That means this total length OQ is root of 13, and we know that the length PQ is the radius, which is equal to 1. So from this total length OQ, if we delete this PQ, we get the required length OP. Yes. Therefore, OP is equal to the length OQ minus PQ, which is equal to root 13 minus 1 unit as answer. When we go through this question, here also we have the same part as the first one. So what you need to do is pause the video and do the first part. So in first part, Z is given as 2 plus 6i divided by 1 minus 2i. And we have to express it in the form of x plus iy. That means in the Cartesian form. So what we need to do is simplify it. So to simplify it, like the previous question, multiply the conjugate of 1 minus 2i in numerator and denominator. So we get it as 2 plus 6i into 1 plus 2i, which is the conjugate of 1 minus 2i, divided by 1 minus 2i into 1 plus 2i. That is equal to, when you expand the bracket, we get 2 plus 4i plus 6i plus 12i squared, whole divided by 1 squared minus 2i squared, in the form of a squared minus b squared. So that's equal to 2 plus 4i plus 6i as 10i plus 12i squared becomes minus 12, because I squared is minus 1, divided by 5. That's equal to minus 10 plus 10i divided by 5. It can be written as minus 2 plus 2i. So this is the answer for this question. Okay, and the second part of the question is express it in the form of r cos theta plus I sin theta. That means we have to express it in the form of modulus argument form. And as the z is simplified as minus 2 plus 2i, we can say x is minus 2 and y is 2. So we can find the value of r, which is modulus z. So that is equal to under the root x squared plus y squared, which is equal to root of minus 2 squared plus 2 squared, which is equal to square root of 8. So we get the value of r as square root of 8. Now to find theta, which is argument of z, let's make the rough diagram. As our coordinate is -2, 2, it lies in the second quadrant, same like our previous question. If you assume that one as A, or A is the position vector, so that this is our argument theta. So here, as this is theta, theta lies in the second quadrant. Let's find the value of alpha. To find the value of alpha, let's complete this right triangle with vertical line is 2 and the horizontal one is also 2, so that we get alpha as tan inverse 2 by 2, which is tan inverse 1. And here you have to make an expansion, a description about theta. What is that? The point A -2, 2 lies in quadrant 2. Therefore, theta is positive and theta is equal to pi minus alpha, which is equal to pi minus tan inverse 1, which is pi minus tan inverse 1. What is pi minus tan inverse 1? Is 0.785. That's the value of theta. Therefore, r of cos theta plus I sin theta is √8 of cos 0.785 plus I sin 0.785 as a result. The next part of the question is about Argon diagram. On a sketch of an Argon diagram, shade the region whose points represent the complex numbers z satisfying both the inequalities mod z minus 3i less than or equal to 1 and a real value of z less than or equal to 0, where REZ denotes the real part of z. Find the greatest value of argument of z. We have to find the greatest value of argument of z. So before going for that, let's make the Argon diagram. Real axis, imaginary axis, and let's take this mod z. It looks like mod z minus z1 less than or equal to r. You know, it represents, the locus represent the circular region, with circumference. Remember the concept, like mod z minus z1 is equal to r, mod z minus z1 less than r, and mod z minus z1 less than or equal to r. It represents the locus as the a circle with only circumference. It represents the circumference of the circle. And it represents the circular region without circumference. And this one represents circular region with circumference. And in this case, we use dotted lines as circumference. And in this case, we use solid line to represent the circumference. Okay, so let's make the circle. Let's make the locus here. So when you compare these two, we get Z1 is 3i and R is 1. Z is 3i, looks like 0 plus 3i. That represents the center as x0 and y3. x0 and y3. Okay, and radius is 1. Now let's mark these points. Center 0, 3. For that, let's make 1, 2, 3. So center is 0, 3. Center is 0, 3. And with radius as 1, we have to make a circle. Radius as 1 means it goes like this. Prepare a proper circle. Okay, with radius 1. Now, not only this circumference, this whole region represents the locus of the first part. Okay, but we need to represent one more locus here. Is real part of z less than or equal to 0. In this z, we want the real part less than or equal to 0. Real part less than or equal to 0 means we want only this region. Yes, that means we do not want this part. So the locus represent this shaded region. Okay, therefore shaded region represents the locus. That is fine. Now let's move to the second part of the question. In this question they are asking us to find the greatest value of arg z. We want the greatest value of arg z. And remember, what is arg z? What is arg z? It is the angle between positive real axis and position vector. Arg z is theta, which represents the angle between positive real axis and position vector. And here position vector is formed by the origin and the moving point. You know, on a circle there will be a fixed point which is the center, and there will be a moving point P. Pxy considered as the moving point with vector, position vector OP is equal to Z. And this point moves. Suppose the point P is here, O is here. Now when you join OP, the angle so formed here is arg z. Okay, like this, how many angles can be found out? Yes, we can find infinite number of angles, because every point of this P makes a position vector, so that angle between real axis and that position vector makes arg z. So there will be infinite number of angles can be formed like this, but among this infinite number of angles, one angle will be the largest one and one will be the smallest one. One will be the greatest one and another one will be the least one. So can you say which is the greatest one here? Yes, it looks like if your position vector is here. If your position vector looks like this, That means if your point P is here, that means it is a tangent. So that this will be the greatest argument. Okay, that means the point P is here. So we need to find this angle here. Okay, let's see how to find that angle. So OP is the position vector, so that this angle will be the greatest possible angle for this question. Okay, that means if your position vector, it cannot be more than this. So the movement of the position vector will be like this still. That means this angle is becoming still smaller. And you know which will be the smallest or least argument? It will be like this. This will be the least argument. And you can see both are tangents. So OP is a tangent. And now we have to find angle theta. And the plan for angle theta is very simple. Look, this angle theta is the sum of this right angle and this smallest angle. That means if you add these two angles, means which angles? Right angle and this angle. As we do not know that angle, let's call that one as alpha. We get the value of theta. Now our task is to find alpha. So to find alpha, what we can do is, let's join this point P and the center of the circle. And you know that is the radius, which is 1 unit. So that a right triangle is formed, because this angle is pi by 2. Why? Because radius is perpendicular to the tangent. That is one of the what we say, angle properties of circle. Radius is perpendicular to the tangent through the point of contact. We have learned that in IGCSE classes. So as it is a perpendicular one, we can say this triangle is a right angled triangle. Let's make that triangle once again. This is the angle we required. And you know, when we take this angle, 1 is the opposite side and 2 is the hypotenuse. Sorry, it's not 2, it is 3. This length. This length is vertical length, which is 3. So we can use sine. Yes, we can say sine alpha is equal to 1 by 3, opposite side by hypotenuse, or alpha is sine inverse 1 by 3. Therefore, the greatest value of theta is pi by 2 plus alpha, which is sine inverse 1 by 3, which is equal to, what's the value? Pi by 2 plus, which is 1.91 radian. That is the greatest value of argument of Z. When we go through this question, it's given that U is equal to 1 plus 2i. U is equal to 1 plus 2i. And the first question is given that U is a root of x cubed, 2x cubed minus x squared plus 4x plus k is equal to 0. Our question is to find the value of k. we have to find the value of k. So as u is the root of this equation, we can say the one of the values of x is u, which is 1 plus 2i. As u is a root, we can say x is equal to 1 plus 2i. The various values of x can be considered as the root of the equation which satisfies the equation. Okay, so here x is equal to 1 plus 2i, but in your equation you can find x squared and x cubed. That means we have to find out all those values. So let's find out x squared, which is x into x, that means 1 plus 2i into 1 plus 2i. Otherwise we can use a plus b the whole squared. Both will give us the same result. We get 1 plus 2i plus 2i plus 4i squared. 4i squared is minus 4. So 1 minus 4 is minus 3 plus 4i. That is x squared. Now x cubed, we have to find x cubed, which is x squared into x. And you know x squared is this one. So x squared is minus 3 plus 4i into x, 1 plus 2i. Expand the bracket, we get minus 3 minus 6i plus 4i plus 8i squared. 8i squared is minus 8, so minus 8 minus 3 is minus 11 minus 2i, which is x cubed. So we got the value of x, x squared and x cubed. So let's take the equation. 2x cubed minus x squared plus 4x plus k is equal to 0. Become 2 of x cubed minus 11 minus 2i minus x squared minus 3 plus 4i plus 4x. X is 1 plus 2i plus k is equal to 0, which is minus 22 minus 4i plus 3 minus 4i plus 4 plus 8i plus k is equal to 0. Now here you could find minus 4i is minus 8i plus 8i will be 0. So remaining we get minus 22 plus 3 plus 4 is minus 15 plus k is equal to 0, or k is equal to 15. Therefore our equation becomes 2x cubed minus x squared plus 4x plus 15 is equal to 0 as the first part of the equation. And part B is by showing all working and without using a calculator, find the other roots. We have to find the other roots. We know that it has 3 roots because the degree is 3 as it is a cubical equation. And already we know that one root is 1 plus 2i. So as one root is 1 plus 2i, the second root will be 1 minus 2i. So already we got 2 roots. Now our part is to find the third root. So as x is equal to 1 plus 2i is a root, we can say that x minus 1 plus 2i is a factor, and x minus 1 minus 2i is another factor. So let's take the product of these two factors. We get it as x minus 1 minus 2i x minus 1 plus 2i x plus 1 plus 2i into 1 minus 2i. That's equal to, sorry, it is x squared. X into x is x squared. X squared minus x plus 2ix minus 1 into x minus 2ix plus it's y plus b into a minus b. When you do that, we get what we get. Is it 5? 1? Yes, 5. Isn't it? That's equal to x squared plus 2ix and minus 2x cancel. We get minus 2x plus 5. So we got a square factor here. Now we have to find the third factor. So it can be considered as the divisor, not considered, it is the divisor, and this is the dividend. So let's do the division and find out the third factor. So you can try with division. I'll show you another one method. It's nothing but 2x cube minus x square plus 4x plus 15 has a factor as x squared minus 2x plus 15. So it has a square factor now. As it has a square factor, the next factor will be a linear factor. Because when you multiply it, x square into x, we get x cubed. Okay. Now, if you multiply the first terms here, we get x square into ax as ax cubed. And when you take that here, the corresponding value of ax cubed is 2x cubed. So when you compare these two, we get a is equal to 2. And b is the constant. It's not only b. If we multiply 15 and b, is it 15? No, 5. 5 and b, the constant is 5b. And when you look at this, the constant is here 15. So when you compare both this, 5b is equal to 15 or b is equal to 3. Therefore, we can say the third factor is ax plus b. So the next factor is ax plus b. That's equal to 2x plus 3. And to find the root of this, is equal to 0 or x is equal to minus 3 by 2 as the third root. Therefore, the roots of this question is 1 plus 2i, 1 minus 2i, and minus 3 by 2. The next part of the question is, on an Argon diagram, sketch the locus of points representing complex numbers z satisfying the equation mod z minus u is equal to 1. Determine the least value of arc z for points on this locus. Give your answer in radians, correct 2 decimal places. So in the previous question we have discussed the same type of question, but there it was to find the greatest value of arc z. Now we have to find the least value. Let's see how to do this. So our equation is given as mod z minus u is equal to 1. And this equation represents a circle because it is in the form of mod z minus z1 is equal to 1, where z1 is u, which is 1 plus 2i. So we can say z1 is 1 plus 2i. That means it represents the center of the circle, which is 1, 2, because x value is 1 and y value is 2, and the radius is 1. Radius is 1. So when you make the Argon diagram. Real axis, imaginary axis, 1, 2, 3, 4. So when you mark the center as 1, 2, 1, 2, and radius as 1. So as radius as 1, we can draw a circle in this format. Okay, so once our circle is ready, so this is the locus. So what we drawn is the locus. The circumference of the circle represents the locus because the equation is equal to 1. The next part of the question is to find the least value of arc z. And we know that the arc z is an angle between the positive real axis and a position vector formed by the origin and a moving point on the circumference. So here we required a moving point on the circumference. That moving point and the origin forms a position vector, so that an angle formed between positive real axis and the position vector is considered as the arc z. And here we want the least value of arc z. In the previous problem we discussed how to find the greatest value of arc z. Now the least value of arc z comes like a tangent which comes here. So this will be the least value can be formed with arc z. Let's consider this point as P. Now to find that value, we need to complete one more angle, which is let's join O to the center and also QP, so that a right triangle is formed. So we got a right triangle here with center is, what was the center? 1, 2. As the center is 1, 2, we got a right triangle. Now we can find the length of OQ. How do we find the length of OQ? For that, we know that the radius of the circle QP is 1 unit. The radius is 1 unit, and when we think about the length OQ, which is the length we required, when we think about the length OQ, it is the position vector OQ. So OQ is a position vector which is Z1. That is same as U, the question. And the length of OQ can be found by mod Z1, which is equal to under the root 1 squared plus 2 squared, because Q is with a point 1, 2. So which is equal to root of 5. So we get the length OQ is root 5. Length OQ is equal to root 5. Hence, we can find angle QOP, this angle. If you think that angle as alpha, so alpha can be found by sine inverse of 1 by root 5, because when you think about alpha, we have the choice of opposite side and hypotenuse. So we get alpha is equal to sine inverse of 1 by root 5. I am leaving the calculation to you. You have to do the calculation. So we got alpha now. Now our task is to find out another angle. which is, let me remove all these things, we'll make all this later. Now we need to calculate this angle. If you consider that angle as beta, we can find beta is, this side as 1 unit, because the horizontal length is 1 unit and vertical length is 2 units, and of course the hypotenuse is root 5 units. So here we can use any one of the ratios such as sine, cos or tan. By any ways you can find beta as, if I use tangent, we get beta as tan inverse 2 by 1, which is tan inverse 2. Or if you use cos inverse, which you will get cos inverse 1 by root 5. If you use sine inverse, we will get beta as sine inverse 2 by root 5. So anyways we can do that. So that now let's see what is the required angle for us. Now we want the least value of the arg z. For that we draw a line like this, and this is the least value of arg z, which is theta. Now what we have calculated is, we calculated this angle as alpha and this total angle as beta. So this total angle is beta from the figure, and this smaller angle is alpha. So that we get arg z, which is theta, as beta minus alpha. That is equal to, beta is tan inverse 2 minus alpha is sine inverse 1 by root 5. Perform this calculation and get the corresponding result of this.